In this lesson, we're going to take a more in-depth look at the normal distribution, right? Kind of our standard curve for continuous variables. Okay. So we mentioned yesterday that when we have a whole bunch of data, that's things we measure, continuous data, we can often make a histogram, and then if we put a curve over that histogram, we get this lovely shape below that we call symmetrical or normal. Okay. So if you hear me talk about the word normal, I mean this shape. And you might also hear it called a bell curve. Kind of looks like a bell. Here's our handle on top. And down the road in university or college, your prof curves the marks. What he's doing is he's creating a shape where he has a very few people at the top, a few people at the bottom, but most of the people are right here in the middle. Well, if we know things that are normally distributed, we're told that something kind of cool is true. The mean, the median, and the mode all have the exact same value. Okay? And that mean, median, mode is right in the middle of the diagram. Okay? Because of that, it's possible to find the likelihood or probability of different events by finding proportions of that curve based on where the mean falls, because it's also the median, which means I know things like, oh, this is 50% and this is 50%. But I can actually go further with that. Okay? So for example, if we look at the heights of students and we're told they're normally distributed with a mean of 160, oh, I know this number right here is 160, okay, and a standard deviation of 8. Well, what we use that for is we use that for a measuring tool on this normal distribution. So this is the standard deviation. I know the distance is 8 units. Another standard deviation, again, the distance is 8 units. And I can go left and right of that, and I can start dividing this curve into different areas or proportions. Okay, I want to point out to you just for a second here, we have some notation. Okay, our normal distribution, the notation we use is x, and then we have this like squiggly symbol here, and then n for normal, and your mean, and your standard deviation squared, which we know is called the variance. Okay, so just remember when we're doing this, the standard deviation is just the base number, the 8. Okay. Since the normal distribution shows all the data, every possible case, I can find different areas of that curve by creating intervals, as we talked about a second ago. So I can say to myself, what proportion of data is in here? If I know the proportion of the data, I know the probability. So in a case like this, we're going to start using some notation. We want P for probability, and I want my values between 8 and 11. And then we're going to calculate the percentage that actually happens. Okay? Sometimes it's very simple. For instance, in this diagram, if I asked you what is the probability that something is greater than 10, I can figure that out pretty easy because 10 is my mean, which is also my median, and I know my answer is 50%. But I can also use the idea of subdivisions by standard deviations. There's a couple of really cool patterns that happen with the normal distribution. Okay. Number one, obviously we have the mean, the median, and the halfway points. We can use 50%. But it turns out that 68% of the data is always within one standard deviation. So in other words, if I take my mean and I go one standard deviation above it, so that's why I add one, and one standard deviation below it, so I subtract one, I end up with approximately 68%. Technically, if you add these together, it's 68.26, but we'll use the idea of 68. If you go further and you go to 2 standard deviations of the mean, so you go all the way over to here and all the way down below, you end up with 95% of your data. And if you go to 3 standard deviations, it comes out with 99% of our data. Now, that's a long ways away. It's really unusual to be more than 3 standard deviations away from your data because it's 99% of the data. Almost all of it. Only 1% is left over. And technically, actually, if you add all these things together, it's less than 1%. Now, why are those important? Why are those useful? Well, we can use it to make predictions. Predictions about probabilities, or proportions, or percents. All those P words are used interchangeably. So let's take a look at an example here. We have the chest measurements of soccer players. They're normally distributed, which tells me that I have a normal curve. I'm going to draw it. I think at the beginning here, drawing things that will help us solve problems. And they're normally distributed with a mean of 95. So I know that down the middle, that's 95 centimeters. Okay. And I have a standard deviation of 8. So if I go one standard deviation above, I'm at 103. One standard deviation below, 95 minus 8 is 87. If I go two standard deviations, I'm up to 111, or below, I'm down to 79. If I go right to the end, it's so close, it's even hard to tell. Three standard deviations, 119, and over here, 71. And that's what my diagram says to me, and I know some proportions of this curve. Okay, I want to enter some questions. Find the percentage of players with chest measurements between 87 and 103. So, the way we're going to do this, P for percentage or probability, I want to go between 87 and 103. So in my diagram, I notice 87 and 103 is right here. In other words, between one standard deviation below and one standard deviation above, which I know is 68%, or 0.68. It's one of my special numbers within one standard deviation of the mean. And if we try part 2 of that question, between 103 and 111. Again, if I go back to my diagram, 103 to 111 is something I can find. 103 is right here. 111 is right here. It's this bit. Now, how can I calculate how much data is there between 103 and 111? So there's a couple things we can do with this. Okay. The first thing I want to think about is, I know that this is 2 standard deviations. I know this is 1 standard deviations. I know some things about 2 standard deviations and 1 standard deviations. For instance, I know that 1 standard deviation is 68% of my data, and 2 standard deviations is 95% of my data. That means that the difference between those two things, if I subtract them, 95 minus 68, will give me 27% of my data. Well, what does that 27 represent? It represents the difference between 2 standard deviations and 1. In other words, if this is 1 in the middle, and 2 standard deviations is everything, from 79 up to 2 standard deviations, the leftover stuff, the stuff in between, which is the blue areas, comes out to 27%. Now, I don't want both blue areas in this question. I want half of it. I want just this side, the right side. I want to get rid of this one over here. So I can take my 27 and divide it by 2. That tells me I have 0.135 left over. And it's a way of calculating that area of the curve, that proportion. That's one way of doing it. A second way, I'll just redraw the picture real quick here so we can see what's going on. Okay, down the middle is my standard deviation, 95. Mean standard 195, 1 standard deviation, 2 standard deviations. I want to find this. Well, again, if I take the idea that I know 1 standard deviation is 68, so this half is 68 over 2, or in other words, 34%. And I also know that 2 standard deviations is 95, but I only have half of it. So I have 47.5%. Well, the difference between those, in other words, the shaded part right here, is the difference between these two values. How far apart are 34 and 47.5? Well, that's 0.135, or 13.5%. And so I can use this idea of curves and proportion and percent to actually calculate some probabilities. Let's try part B. The probability of the chest measurements of a player are between 87 and 111. 87 and 111. Okay, so I'm draw my picture again real quick. We'll get real good at drawing these pictures. Curve, middle, 95. Go 1 standard deviation is 103, 111. One below is 87 and 79. And I want in part B here between 87 and 111. So 87 up to 111. So I want to know all of this. So what do I got? Oh, I can think of this as two parts. I know this part from 87 to 103 is 68%. I also know from a previous question that 103 to 111, this section here, is 13.5%. So I know that the answer is those two things combined. In other words, 0.68 plus 0.135, or if you will, 0.815. There's my probability. Now that's not the only way you could do it. That's a pretty handy way. The other way I could have done it is take the idea of, I know from 79 up to 111 is 95%, and I need to get rid of the section from here to here, which I already figured out, that was 13.5. So the other thing I could have done is 95 minus 13.5, which is the same answer. Now notice I go back and forth between percents and decimals. These two things are used interchangeably. I like to work in decimals unless it says I have to work in percents, and I'd be willing to let you guys do the same thing. Now I'll try a second example, different numbers. So the weights of 10,000 students are normally distributed. The mean of the weights is 55, the standard deviation is 5. Can we draw ourselves a picture? So what do we got? Normal, mean, okay, 1 standard deviation, 2 standard deviations, 3 standard deviations. 1 standard deviation, 2 standard deviations, 3 standard deviations. And notice that they should all be the same size, right? It's my scale. Okay, part A wants us to find the number of students between 50 and 60. So let's find our proportion, our probability between 50 and 60. Well, that's a nice one. That's 1 standard deviation each direction. So in other words, it's 0.68. This time, though, the question asks us to find the number of students. Okay, we looked at 10,000 students to begin with, so our number of students can be calculated by finding the proportion of that 10,000. We know it's 68% of 10,000. So we can multiply those two things together to get our actual number of students, 6,800. Okay, let's find part B here, the less than 45. The less than 45 is down here. I want to find all of this. In other words, I want this right here to the corner. So how am I going to calculate that? Well, let's think about this. What do we know? We know this is 2 standard deviations. What do I know about 2 standard deviations? I know that's 95%. But it's 95% between 2 standard deviations. In other words, there's 95% in here. So I actually know something about what's left over. The stuff that's left over is 5%, right? There's 5% combined between this and this. But I don't want this half, I only want this half. So if I take my 5% and divide it by 2, I know what's left over. So what's the number of students weighing less than 45? Well, the probability of that is 0.025, half of 5%, the remaining 5%. Well, my number of students then will be 10,000 times 0.025, or in other words, 250 students. Okay, part C. Find a range of weights that will include 99% of the measures. In other words, what includes 99% of these students? Well, we know that 99% is a magic number. It's the mean plus or minus 3 standard deviations. In other words, the range that includes them goes from a low of 40 up to a high of 70. It'd be really strange to get somebody who weighs outside that range, because that includes 99% of the students. There's only 1% left over who isn't in that range. Okay, so there's a brief introduction to how we can use a normal distribution and the ideas of proportion of the curve. Okay, our magic numbers today are 68, 95, and 99. And it's going to take a little practice playing with these numbers to figure out what portions we want, the left side, the right side, the between. Draw the diagrams. My best suggestion to you is start coloring on that diagram so you know which parts and pieces you need. Our homework today is a handout, the answers to which are on the website. You can check things out. If you're stuck, come see me. And then tomorrow we'll move on to other things you can do with the normal distribution.